All right, so in this lesson, I'm going to go over finding the greatest common factor of a number, or of two numbers, and finding the least common multiple. So let's start with the greatest common factor. So finding the greatest common factor is exactly what it says. You're looking for the biggest factor that these two numbers have in common. So the biggest factor that they share. Another way of thinking of it is the biggest number that you can divide each of these by. So we use greatest common factor when we're simplifying fractions. So if I was simplifying 24 over 64, I'd want to know what's the largest number that I can divide them both by. And that's called the greatest common factor. So one method of doing this is to just list the factors of each number and see what's the biggest one that they have in common. So the factors are the numbers that you can multiply together to make 24. So the first two factors would be 1 and 24. And then you have 2 times 12. And then 3 times 8. And you can see the better you know your multiplication tables, the easier this is going to be. If you don't know your multiplication tables, this is almost impossible. And then the last two would be 4 and 6. So those are the factors of 24. It's all the numbers that can be divided out of 24, or in other words, the numbers that can be multiplied together to make 24. And then we'll do the same thing for 64. So 1 and 64. And then I have 2 and 32. And then let's see, 4 and 16. So this one's a little bit harder. 16 and and then 8 times 8. So we don't need to list both the 8s. I can just list it once. So there's the factors of 64. So what we're looking for is the greatest one, the largest one they have in common. So if we look at these, the greatest common factor would be 8. So the GCF is 8. So that would be the largest number that you could divide each of these by. All right, so the other method involves using the prime factorization. So prime numbers are numbers that are divisible only by 1 and themselves. So they have to be divisible by exactly 2 things. So usually if you're doing factoring, you would do a factor tree. So let's see what a factor tree looks like. So I'll start with the 24. And so 24 factors into 8 and 3. And then 3 is a prime number. So I just keep going until I have just prime numbers. 8 could be 4 times 2. 2 is a prime number. And then the 4 factors into 2 and 2. So the prime factorization of 24 is 2 times 2 times 2 times 3. So if you multiply 2 times 2 times 2 times 3, you'll get 24. 2 times 2 is 4, times 2 is 8, times 3 is 24. And then we're going to do the same thing for 64. Start with 64, and I'll start with 8 and 8. So 8 times 8. So that factors to 4 times 2. 2 is prime, so I'm done with that one. The 4 goes to 2 and 2. And then this goes to 2 times 4. And that goes to 2 and 2. So the branches here, the very ends of them, that's your prime factorization. So the prime factorization of 64 is there's 1, 2, 3, 4, 5, 6 2's multiplied together. So 1, 2, 3, 4, 5, 6. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So how do we find the greatest common factor now that we have the prime factorization? So the product of the common prime factors is the GCF. It's the greatest common factor. So all you're going to do is look for common prime factors. So they have 2, 2, and 2. So there's 3 2's that they have in common. This one has 3 2's, and this one has 3 2's. And there's no 3 over here, so that doesn't work. So the greatest common factor, we just take the product of the common factors. So the common factors that they have are 2, 2, and 2. There's 3 of them, right? These 3 and those 3 are in common. Multiply those together, and you get 8. So the greatest common factor is 8. So you can use either method. Method 1 is probably the easiest method. Method 2 you would really want to use if it's a really big number and you have no clue what the factors are. All right, so now let's look at least common multiple. So multiples of numbers just mean counting by that number. So like the multiples of 12 would be 12, 24, 36, 48, 60, 72, and so on. And what you're looking for is the smallest multiple that they have in common. Smallest multiple they have in common. So method 1 is to just start writing down the multiples of each number until you get to the smallest one they have in common. So the first multiple is obviously 12, right? And then, sorry, I didn't write 12 there. So that one would be 18. All I'm doing is counting by 12s and counting by 18. So 12 plus 12 is 24. 18 plus 18 is 36. 24 plus 12 is 36. 36 plus 18 is 54. And actually, I can stop. So as soon as I get a common multiple, I'm done, because you're wanting the smallest multiple that they have in common. So the least common multiple is 36. Now, where you use least common multiple is when you're finding a common denominator, when you're adding or subtracting fractions. And you need to get a common denominator, you're finding the least common multiple. All right, so let's look at method number 2. So method number 2, just like method 2 on the last one, involves using the prime factorization. So we're going to factor 12. So that would factor to 4 times 3. 3 is prime, so I'm done there. 4 factors to 2 times 2. So the prime factorization of 12 is 2 times 2 times 3. And then do the same thing for 18. So for 18, let's do 9 times 2. And then the 9 factors to 3 times 3. So the prime factorization is 2 times 3 times 3. All right, so now how do we use this prime factorization to find the least common multiple? So what we do is we use each prime factor the greatest number of times it appears in either number. So what does that mean? Okay, so we have a factor of 2, right? There's 2 2's here, and there's 1 2 there. In the least common multiple, I want to use each factor the most number of times it occurs. So over here it occurs twice, so I'm going to use it twice. And then I go to the next factor, which is 3. There's 1 here and 2 there. So I'm going to use the 2. So multiply these together. 2 times 2 is 4, times 3 is 12, times 3 is 36. So there were 2 2's. That was the most 2's that occurred in either number. And there were 2 3's, and I multiply those together. So again, you can choose to use either method. All right, so I hope you found that helpful and useful. If so, give it a like and a subscribe, and feel free to leave me a comment. Until next time.